Here's my program for the proportional controller. In the first rung, I use a move statement to read in the value of the 0 to 10 volt input, my set point, and I store that away in N70. It's an integer file. It's just there for storing numbers. You can store a number there anywhere from 0 to 32,767. On the second line, we read in the value from the feedback. That's a 4 to 20 milliamp value, so that's a current value. Currently the tank is empty, so it's sitting near the bottom, and the bottom should be 20% of full scale, 20 milliamps being full scale, and it's actually sitting at 6120, where it should be 6553. In my next rung, I scale the current feedback, kind of stretching out the range. I read in N71, tell it that my minimum value is 6553 and my maximum value is 32767, and then I say that that should be spread out on a scale of 0 to 3267, and then I store that number away back in N71 again. Next we calculate the error. The error is the set point minus the feedback. So we read in the set point, which was previously stored in N70, and we read in the feedback, which is currently sitting near 0, and we create an error. Right now my error is 14,357. We take that error and we multiply it by our gain. The gain currently is sitting at 10. We can make that any number we want. So we take that error, 14,357, multiply it by 10, and look at that number. Now the number is actually over 32,767, so we have to do a little math trick to unlatch the overflow trap. No big deal. And then we send that calculated output to the actual output. So on a scale of 32,767, the output voltage, which can range from 0 to 10, is going to go all the way up to 10 volts. That's going to result in a maximum frequency when we start the drive. So let's go start that drive. Cut.